Let's sketch y equals 3x plus 2. The y-intercept is 2, so we go up 2 units and draw a dot. The slope here is 3 over 1. So the rise, the numerator, is up 3, and the run is 1, the denominator, 1 to the right. We now join a line that goes through these 2 points. And here the y-intercept is 2. Let's now sketch this line with this domain restriction. We have y equals negative x plus 2. We're just rearranging these. And when sketching this line, we have a y-intercept of 2. 1, 2, and draw a dot. The slope here is a hidden negative 1 over 1, and the rise is down 1, and the run, positive 1, is 1 to the right. Now we can visualize this line going downhill, and it cuts through the 2 dots. However, x is less than 3. So we have a critical point. When x equals 3, what is y? Y equals negative x plus 2, or negative 3 plus 2, which is negative 1. So we have 1, 2, 3. 3 comma negative 1 is a critical point. 3 comma negative 1 is where the graph begins. It's a ray. And there's a hollow circle here. We don't actually include the endpoint. If this was a less than or equal to sign, we would fill in this hole. But this line, this ray, goes to the left only, not towards the right. Let's sketch part of this parabola. We have this parabola, which is based off y equals x squared, and the minus 2 means we shift 2 to the right, and the plus 2 means 2 up. So the vertex is 2, 2. From the origin, 1, 2, 1, 2 is where this graph begins. Now normally, this would be a happy face parabola that looks like this. However, we have this domain restriction. X is greater than or equals to 1, which is the same thing as this here. And when x equals 1, this critical point, y equals 1 minus 2 squared plus 2. We substituted 1 into x. We have negative 1 squared, which is 1, plus 2 is 3. So we see here that when x equals 1, 1 comma 3 is a critical point. 1 comma 3. And we're going to shade this in because we're including the endpoint. This square bracket means including the endpoint. And we're saying that x is greater than or equals to 1. So we draw part of the graph towards the right. Let's sketch this linear inequality statement. We know how to sketch y equals 3x plus 2. That would look like 2 up, and the slope is 3 over 1, which is up 3 and 1 to the right. So normally we just draw a line this way. Now when dealing with inequality statements, we're not just going to draw the line. We're going to draw above the line because y is greater than this line. So we shade in a solution region, an area. So everything north of this line is a solution region. And we include the actual line as part of the solution region. So it's a solid line because of this equal sign here. If there was no equal sign, it would not be solid. It would be dashed. So now the question is this point 1, 7 in this solution region? Let's use substitution. When x equals 1, is it true that y is greater than or equals to 3x plus 2? Question mark. What we have here is the value 7. Is 7 using substitution, greater than or equals to 3 times 1 plus 2, question mark. The left side is 7, and the right side is 3 plus 2, which is 5. So yes, indeed, 7 is greater than or equals to 5. So we'll say true or yes, this point 1 comma 7 is in the solution region. Normally, when we have the equation y equals 3x plus 2, when we substitute 1 into x, y equals 3 times 1 plus 2. 3 plus 2 is 5. So we would expect 1 comma 5 to be on the line. Now when talking about the y value of 7, 7 is way up here, which is indeed in the solution region.